Let's go to page 237 and start with number 329. So 329, you have 2 points. You got point A and point A prime. You want to prove that giving any 2 points, there's a point O such that A prime is an image of A under reflection through point O. Okay. So any giving 2 points, that if you have a midpoint, if you do the reflection over the point, which is a midpoint, then it will always map, because if this is a midpoint, this would be congruent to that. Let's call this O. So if this is the midpoint, then AO will equal to OA, so you always match. Okay, so that is a point which is the midpoint that will give you the reflection. Okay, so that's it. Okay, so 330. Yeah, you're looking that y equal to mx plus b, and this is the image that when 9x plus 3y plus 11 is equal to 0 is reflected over the x-axis. So if you were to sketch these things out, okay, I'm going to call this L for 9. If you were to put this in the standard form, you get x plus 3y equal to negative 11. And if you were to sketch out, now you don't have to sketch it out, but if you sketch out, it will help you to really see it. So if you get x equal to 0, okay, then your y will equal to negative 11 over 3. If you get y equal to 0, x will equal to negative 11. So if you were to sketch these things out, again, I'm not going to draw this to scale. So 0, negative 11, so it's about right over here. So it'd be 0, negative 11 over 3. And this would be negative 11. And so basically you have this line right over here. Okay? Now, and here's your x-axis. So when you flip it over, this point becomes over here. And so when you flip it over, if you notice that this point would be 0, 11 over 3. Right? And so basically you end up with a new line like this. So what you see is that when you reflect over the x-axis, the y becomes opposite. Okay? So for the reflected line, the y becomes opposite. So basically instead of y, you have a negative y. So basically you have this. So when you reflect over the x-axis, you have the 3 times the y becomes negative y, becomes opposite. Okay, so that's what you're going to have. And so this reflected, so your reflected equation is x minus 3y equal to negative 11. Okay, and then if you were to solve, you're going to get this point. So if you let x equal to 0, you get y equal to 11 over 3. Okay, and that's what we see that. Okay, if you let y equal to 0, then you got x equal to negative 11, which is the same point over here. Okay. Okay, but anyway, so from here, from this equation, we can see that the slope. So you want to put in this form, right? So let's go and do that. Okay, so you have a x minus 3y is equal to negative 11. So you move things over. So you have to put in this form to looking for the m plus b. So you got negative 3y equal to negative x minus 11. Then you divide by negative 3, divide by negative 3, divide by negative 3. Again, all this is just kind of to show you, how they are all connected. Okay. So again, when you reflect over the x, the y becomes negative y, and you get this equation. And from there, you can put in this form. So you got y equal to 1/3 x plus 11 over 3. So that's your m, and that's your b. Okay. So m plus b will equal to 1/3 plus 11 over 3. So this will equal to 4. Okay. And that's it for number 330. Okay, let's go to 331. So you got points Okay, so this one, I'm not going to draw to scale. So you got P0 at 0, 0, and you got P1 over here at 3, 4. Okay, and so you want to flip the P1 over the P0 to get the P2. So this would be the P2. Okay, and you're going to flip over. You're going to just continue. So P2 flip over P1 to get P3. So P3 is going to be over here. Then you're going to flip P3 over P2 to get P4. Okay, so that's what that is. And you're looking for the A plus B. Okay, so from here, so that's going to do the P2 first. Okay, so I'm going to call this X2, Y2. Okay, so this is going to be the midpoint. So X2 plus 3 over 2 will equal to 0. Okay, and you can see it's going to be the negative, right? But let's just follow through. So Y2 plus 4 over 2 equal to 0, right? Because this is the midpoint. So you work it out. So x plus 3 equal to 0. So x2 equal to negative 3. Okay, so P2, this would be negative 3, and this one would be y2 plus 4 equal to 0. So y2 equal to negative 4. So this would be negative 3, negative 4. Okay, again, because when you reflect over, right? Okay. And you could do the same process. So now you have to get P3. So you're going to get X3. So now P1 is your midpoint, right? Again, so you reflect over, so P1 is your midpoint. So you're going to get X3 plus negative 3 over 2 will equal to 3. And the Y3 plus negative 4 over 2, you add, your average will give you the midpoint. So cross multiply, and you add 3. So X3 will equal to 9. Cross multiply, plus 4. So you got Y3 equal to 12. So this is going to be 9, 12. Okay. So now you're going to make this the midpoint. You're going to reflect P3 over the P2 to get P4. Okay. So now you can just follow the same stuff, same step, right? So you're going to get X4. Okay. So you're going to average the two. So X4 plus 9 over 2 will give you the midpoint. Okay. So the Y4, you can see this over here. So Y4 plus 12, right, this 2 points you add, you get a midpoint. Okay, so you add, divide by 2, you get negative 4. So now you solve, so you got X4 plus 9 equal to negative 6. So minus 9. So X4 equal to negative 15. So cross multiply, you got Y4 plus 12 equal to negative 8. Then you minus 12 minus 12. So you got Y4 equal to negative 20. So the P4 would be negative 15, negative 20. And so that's your A and the B. And so A plus B equal to negative 15 plus negative 20, so equal to negative 35. Okay, and that's it for number 331. Okay, let's go to 332. Okay, 332, it says two successive clockwise rotation about the origin of the angle x and the y. And the x and the y is between 0 and pi, so between 0 and 180 degrees. Result of reflection to the origin. Okay, well, when you have reflection over the origin, means you rotate 180 degrees. So x plus y is 180 degrees. So that's it. Okay. So again, a reflection to the origin, a reflection over a point is rotation of 180 degrees. So x plus y, so you rotate, so it would be total of 180 degrees. Okay, let's go to number 333. Okay, so basically you have a triangle. And it's called this AB, and you're going to rotate about a point O, and you're going to end up right somewhere over here. Okay. Okay, this is. Okay, there we go. Okay, so this is AB, and it's going to rotate to CD. Okay, so you want to prove that if the A rotate and map into C, B map into D, you want to prove that AB matching to CD. So what you want to do is you want to pick a random point over here. Let's call it X. So any point. You want to prove that any point on here we're able to rotate and map onto point somewhere over here. Okay. Okay. So we're going to call this Y, and we're going to label this Y over here. Okay, so we're going to call this theta, and we're going to rotate theta. Okay. And now what we're going to do, we're going to prove that all x equal to all y. Okay. If we can prove that all x equal to all y, that means this point will end up on CD. Now, if all x is not equal to all y, that means when you rotate, it will be out here somewhere out here. Okay. But if all x is congruent to all y, that means this point will be on CD. That means any point will be then any point on the CD. So again, if all x is not equal to all y, that means the y can be anywhere out here. That means this when you rotate, it will be out here somewhere. But if all x equal to all y, that means this point will end up right over here. Okay. Okay. So, and also notice that angle A is congruent to angle C. Okay. And we're going to rotate. We're going to draw this, and we're going to rotate the same amount. Okay. So the angle AOX. Now that's the angle. Okay. So angle COY is congruent to angle AOX. Okay. So that these are congruent. Okay. And this were congruent. And also we know that when you draw this segment, right, that CO since this is the same point, so when we draw this, the CO will be congruent to CA. Okay, so this will be congruent. Okay, because when we do a rotation, the distance will be preserved, right? So now you can see that triangle COY is congruent to triangle AOX. Okay, so this triangle, this would be the ASA. So now if the two triangles are congruent, then we can say that OY is congruent to OX. Okay, so that means that since it's the same distance, so that means the point Y is on CD. Okay. So any point like X okay, on AB we map to a point on CD, and that's Y, okay? And that's it for number 333. Okay, let's go to 334. Okay, so 334, you have an isosceles triangle. So you got A, B, and C. Okay. And so it tells you AB is equal to AC and BAC equal to alpha. Okay, and there's a circumcenter O. So you have a circle that going around this triangle. Okay, this one here. Okay, so you have this point O right over here. So you want to prove that there exists rotations about both A and O which carries AB to AC. Okay, so let's do the point using the A as the rotation. So if you rotation about A, it's very simple. Okay, you just go and rotate this onto here, and so in this case you just rotate alpha. Okay, rotate alpha, and actually it's negative direction, right? Because so you're negative alpha, so you're going this way, and so negative alpha, and that would give you using A as your point, right? So you can A as your point of rotation, so you rotate, so AB will map into AC. Okay. Now the next is you want to use O as so next one is, so this is the center of that big circle, right? Imagine that this is the center of the big circle, so it rotates. Next one is you have to think of rotate this way. So you have to kind of, in this case, you have to kind of use this as a center of rotation. So when you rotate, you have to rotate this way so that A becomes C. So A rotate to C, and B, so I can hit your center of rotation. You have to look at this circle, okay? So before we look at a bigger circle with this as a center, okay? So A is a center, so when you rotate, that's the easy one. So now you have to make this as a center, so you look at a smaller circle. So you have to rotate this way so that you go A to C and B. So you rotate A to C and B becomes A, okay? And it did not ask you for the angle, okay, for this problem, okay? And so that's it. Now when you get to 335, this is when you ask for the angle, okay? So it's kind of continuation of this problem. Okay. So this one, you have, so again, this is kind of continuation of that. Okay, so but they use a different, so let's see. Yeah. Okay, so again you got A, B, C, and here's the O. Okay, so you have a point over here. So now again the same problem. Okay, now you want to see, so this is congruent to this. Okay, so you want to find out how many degrees you have to rotate so that this will map onto here. So this is the same problem as this one here. Okay, and so here's the alpha, right? So what you do is you cut this into two. So this is alpha over 2, alpha over 2. Okay, now again, this is the isosceles triangle like this one up here. So each of this angle would be, so this angle would be 180 minus alpha over 2, right? Okay, because this is an isosceles triangle, so 180 minus that will equal to sum of this, and you divide by 2. Okay, so this would be 180 minus alpha over 2. Okay. Now remember to map this onto here, you have to rotate. When you rotate this way, basically you have A to C, B to, so when you have A, B, you rotate to here. So this becomes A, and this becomes B. So basically that's what you're doing. Okay. Well, it's actually fairly easy because from A to C, okay, you have to rotate from A to C. So what happens is that the angle A is equal to alpha, angle B equal to angle C equal to 180 minus alpha over 2, right? Because the sum of 3 angles have to equal to 180, right? So angle ABC have to equal to 180, right? So 180 minus that angle divided by 2, right? So that's how you get each of this angle. Okay. Now remember, angle B is an inscribed angle. This will be equal to 1/2 of the arc AC, right? But we know what B is, right? From here, so you got 180. So you got 180 minus alpha over 2 equal to 1/2 arc AC. And times by 2, so you got 180 minus alpha equal to arc AC. Okay, and that's what we need. Okay, so answer is 180 minus alpha. That's how much you have to. That's how much you have to rotate about this point. For number 335.